Okay. Anyways, magnetic length is less than geometric length. That is around 84%. The magnetic field formula can be derived similar to that of electric field formula. It was 1 by 4 pi epsilon naught q by r square for electric field. It will be mu naught by 4 pi qm by r square for magnetic field. To derive an expression for the magnetic field, we just have to replace 1 by epsilon naught as mu naught and q by qm. When a magnet is divided into two parts, or when magnet is broken, we are not able to separate their poles. It will form another dipole. It will form another magnetic moment, another magnetic dipole having a relatively smaller magnetic dipole moment. Right. So when a magnet is broken, we are not able to separate them. It is formed another dipole with a different dipole moment. Now, if there are two magnets combined together, joined together forcibly, because south pole ऐसे तो repel करेंगे. So when we tie them together, it will behave like another magnet of magnet dipole given as a dipole moment formula. Force between two magnets is like force between two electric dipoles, which is inversely proportional to r to the power 4. Distance double करेंगे, then force will become 1 by 16 times. If we have to find force between any two large magnets which are placed near to each other, the previous formula is only applicable for a short bar magnet, and when the distance between them is quite larger than the length of the magnet. So between one pole to another pole, the formula can be derived similar to that of an electric formula, electric field formula, like the Coulomb's law. 1 by 4 pi epsilon naught q1 q2 by r square. Here it become mu naught by 4 pi qm1 qm2 by r square. So on this pole, on the second magnet, north pole repel karega, south pole attract karega. On the other south pole, north pole will attract and south pole will repel. So on any magnet, there will be four forces. Two attractive and two repulsive. We'll calculate them separately and then we find the result. Axial position में magnet की magnetic field similar to that of electric field due to electric dipole. 1 by 4 pi epsilon naught 2 pr. Here it becomes mu naught by 4 pi 2 mr by r square minus a square. So again, in the case of dipole moment formula, इलेक्ट्रिक डायपोल के फॉर्मूले को अगर हमें मैग्नेटिक डायपोल के फॉर्मूले में चेंज करना हो, देन जस्ट अगेन P को M में चेंज कर लेंगे, 1 by epsilon naught को mu naught. Right? Short magnet के लिए it is r square minus a square is approximately equal to r square. A is very very small, so ये बन जाएगा mu naught by 4 pi 2m by r cube. Okay, so all the formulas are similar to that of अगर हम magnet को change करते हैं, magnet की length change कर देते हैं by shortest distance between the north pole and south pole will be considered as magnetic length. Magnet behavior will change. Net flux passing through any closed surface is always zero. Magnetic dipole यानी magnet को अगर हम किसी external field में रखते हैं, then north pole and south pole have equal opposite force, but it provides torque, and that torque is given as mv sin theta, which is similar to p sin theta of electric dipole. Theta is equal to 0 is the position of stable equilibrium. Theta 180 is position of unstable equilibrium, and there is a torque applied on it, which is acting as a restoring torque, though, so it starts performing angular SHM. Correct? Okay, potential energy and work done. So now next part that we have to start is Earth's magnetic field. Earth is also having its own magnetic field. What are the sources and what is the use? First of all, जो अर्थ की मैग्नेटिक फील्ड है उसका कोई रोल है या ऐसे ही फर्जी है वो, मतलब if suppose अर्थ मैग्नेटिक फील्ड does not exist, will there be any harm? कुछ फर्क पड़ेगा हमारे ऊपर? Right, again, will there be any change in our lives if there is no magnetic field due to earth? My question is clear?
So I read something about the magnetic field deflecting off harmful rays from the sun.
We discussed this.
I think so. It was in a different class in school. I mean, you did, sir.
Yeah. Maybe on Friday, right? I also remember discussing something like that. So yeah, every planet which has a metallic core has its own magnetic field because of the rotation of that core there is a current, and because of that rotating current there is magnetic field, and that magnetic field will behave like it's a magnetic field due to a bar magnet. So Earth has its own magnetic field, and what is the source of that magnetic field? Is a rotating coil. There is a Earth rotating. Earth has a magnet. Earth has a molten lava. Molten lava means it is a high temperature metal, so there are electrons available, and those electrons revolve in the circular orbit. As a result, Earth produces its own magnetic field. If we assume that Earth to be like a spherical shape, it's not a perfect sphere though. Earth is rotating on its axis, which is called geographic axis. On that geographic axis, we didn't discuss the elements of Earth magnetic field, right?
No, sir.
No? Did we discuss the elements of Earth's magnetic field?
No, sir, we haven't.
Okay. So this is a geographic axis on which the Earth is rotating. इस axis पे जो poles हैं, these are called North Pole and South Pole. The North and South that we know. This is the geographic North Pole and geographic South Pole. So what is the meaning of this geographic North and geographic South? Because of the rotation of Earth, इसके perpendicular एक equator है. From west to east, electrons are moving. Electron will start rotating from west to east. Current will be from east to west. So if current is from east to west, current इधर से बाहर निकल रही है, east से west की तरफ जा रही है. So if we curl our finger from east to west, then the direction of magnetic field is coming out from the south. So that means from the Earth we can consider there is magnetic field coming out of from south direction. You understood this logic? Because electron is going from west to east, Earth is rotating from west to east. Due to that rotation, Earth has its electric current from east to west. So there is a magnetic axis on which we can assume Earth's magnet to be present. The Earth magnet, if we assume that there is a magnet inside, so जिधर अर्थ के साउथ है उधर अर्थ के मैग्नेट का नॉर्थ पोल है, और जिधर अर्थ का नॉर्थ है उधर अर्थ के मैग्नेट का साउथ पोल है. Magnetic field lines are originated from north to नीचे की तरफ से आएंगी, but since this point is towards south, this place is called south magnetic pole and this place is called north magnetic pole. But magnetic north pole is actually south pole of Earth's magnet, and magnetic north pole is actually south pole of. So magnetic field start from north. साउथ से निकलती है और नॉर्थ की तरफ जाती है. दिस इज द शेप ऑफ अर्थ्स मैग्नेटिक फील्ड. अर्थ के साउथ से निकल के नॉर्थ में जाती है, बट मैग्नेट के लिए तो नॉर्थ से निकल के साउथ में जा रही है. एंड इन दिस वे अर्थ हैज इट्स ओन मैग्नेटिक फील्ड. इस मैग्नेटिक फील्ड का बहुत सारे एप्लीकेशंस है, जीपीएस में, ब्लड सर्कुलेशन में, हार्मफुल कॉस्मिक पार्टिकल से बचाने में. These are the application of the Earth's magnetic field.
Can you repeat this?
Which part? The magnetic field part?
Yes, sir.
The direction of Earth's magnetic field?
Yes, sir. Everything after that. I think my internet got choppy.
Okay. So see, the Earth is rotating from west to east. Electron inside is rotating from west to east. As a result, we can assume the current from east to west. If current is going from east to west, means it is coming out from east and going into the west. Then if you curl your right hand from east to west, thumb is coming out from downward direction. So thumb नीचे की तरफ से means magnetic field नीचे की तरफ से, and that direction is closer to south. This is called south magnetic pole. अर्थ के मैग्नेट का नॉर्थ किधर है? अर्थ के साउथ की तरफ. अगर हम अर्थ के अंदर एक मैग्नेट अज्यूम कर ले, उस मैग्नेट का नॉर्थ पोल है अर्थ के साउथ पोल की तरफ, और उस मैग्नेट का साउथ पोल है अर्थ के नॉर्थ की तरफ. राइट?
Yes, sir.
So there are two different mapping of Earth. One is in terms of geographic axis, geographic equator, geographic longitude and latitude. Another is magnetic axis, magnetic equator and magnetic longitude and latitude. So जब भी हमें GPS use करना है, we have to use with the proper formation that in which direction is the actual north, in which direction is the magnetic north. अर्थ की मैग्नेटिक फील्ड के कंपोनेंट्स तो खैर दो ही होते हैं किसी भी वेक्टर के, but there are three elements of Earth's magnetic field which we require if we want to use it for the navigation purpose, or if we want to use it for, if we want a complete information of Earth's magnetic field using compass. What are those three components? First is called angle of components or other elements. Three elements of Earth's magnetic field. पहला एलिमेंट है एंगल ऑफ डिक्लिनेशन, which is required for the exact information of the direction. हम कंपास को यूज करके अगर नॉर्थ जा रहे हैं, if we move in that direction which compass shows, north direction which compass shows, then we will be able to reach which north pole? Geometric north pole or magnetic north pole?
Magnetic north.
Magnetic north, because it is always pointing in that direction only. So that means obviously we will not be able to reach the exact north pole. We are slightly declined. Similarly, at any point on the earth, the north that pointer is pointing of compass is not the real north. जो नॉर्थ कंपास शो करेगा वो रियल नॉर्थ नहीं है, वो कौन सा नॉर्थ है? दैट इज मैग्नेटिक नॉर्थ. द नॉर्थ शोन बाय द कंपास इज नॉट द रियल नॉर्थ, दैट इज द मैग्नेटिक नॉर्थ. सो हम अर्थ को अगर वर्टिकल सर्कल में डिवाइड करते हैं, दैट इज कॉल्ड लॉन्गिट्यूड. हॉरिजॉन्टल सर्कल में दैट्स कॉल्ड लैटिट्यूड. और उनमें से वो वाला वर्टिकल सर्कल जो पोल से भी पास होता है, that is called meridian, which determines the time zone of any particular place on earth. Right, so this will be called a magnetic meridian and a geographic meridian. Magnetic meridian is that vertical circle which joins the magnetic north pole, magnetic south pole, and at any place on earth. Another meridian is geographic meridian that joins geographic south pole, geographic north pole, and some place on earth. So the orange color one is the geographic meridian, and the blue color one is magnetic meridian. So अगर हमारे हाथ में कोई compass है and we are holding that compass at this place on earth, it will be pointing towards the magnetic north. Diagram थोड़ा अच्छे से समझना. This will be the north shown by the compass, and the actual north is the orange color one. The north between the angle between the true north and the angle shown by the north shown by the magnet. Angle between them is called angle of declination. At any place, the north direction and the north shown by compass are two different directions. The angle between them is called angle of declination. Technical words, the angle between magnetic meridian and geographic meridian. बेटा ये समझ में आया कौन सा एंगल है? किसी भी जगह पे खड़े होकर अगर हम कंपास हाथ में लेते हैं तो एक तो नॉर्थ डायरेक्शन है वो जो कंपास शो कर रहा है, और दूसरा वो जो एक्चुअल नॉर्थ डायरेक्शन है. The angle between magnetic meridian and geographic meridian. This is the technical definition that you will write. This is defined as angle of declination. ठीक है. Practical language is the north shown by compass and the actual north direction. The angle between the true north and the magnetic north, that angle is called angle of declination. बेटा समझ में आ गया? What is the angle of declination? Clear?
Yes, sir.
Bharat,
Yes, sir.
you understood?
Yes, sir. I'm understanding and taking in class
Taking
notes.
Okay, very nice. So the other language is just for the understanding purpose, Angle between the north shown by magnet and the actual north direction is defined as the angle of declination. It is 11.3 at the angle between geographic axis and magnetic axis. Right? Okay. So next one is angle of inclination or angle of dip. Angle of inclination or angle of dip. There are two different angles, and let's say we denote it by delta. But before that, one more component is required, that is called horizontal component of Earth's magnetic field. So if we see from the side view, this is the south pole of Earth, this is the north pole of Earth. The magnetic field line start from the south pole. So ये magnetic south समझ लेते हैं. It start from the magnetic south and goes into the originate from south and then it move towards the north. This is the magnetic south. So in case of the Earth's magnetic field, it originates from the south pole, which is always perpendicular. It goes into the north pole, which is also perpendicular, but exactly at the equator, it is horizontal. If we take at any point in the southern hemisphere, अगर हम खड़े होकर देखेंगे तो ये magnetic field ऊपर की तरफ जा रही है. This magnetic field is going above the Earth's surface. If we are in the northern hemisphere, this magnetic field is going below the horizon. So if we resolve, the Earth's magnetic field has two components. One is parallel to Earth's surface, another is perpendicular to Earth's surface. The component of Earth's magnetic field parallel to Earth's surface is called VH. That is horizontal component, and perpendicular to this is called BV. Likewise, in the northern hemisphere also, BH is the component which is parallel to Earth. BV is the perpendicular to Earth. At the poles where magnetic field start, there is no horizontal component. So all of the magnetic field is in vertical direction only. At the equator, all of the magnetic field is in the form of horizontal component. Vertical component is zero. Right? So पहले हम ये वाला component लिख लेते हैं. There is another component called as horizontal component of Earth's magnetic field. This is third one. Horizontal component of Earth's magnetic field. So quite obviously इसको define कैसे करेंगे? Earth की magnetic field का वो component जो Earth के parallel है, surface के parallel. Horizontal component of Earth's magnetic field. Usually denoted by BH. The component parallel to Earth's surface. अब ये जो इंक्लिनेशन एंगल है या डीप एंगल है, व्हाई देयर आर टू नेम्स. अगर हमारे पास कोई मैग्नेटिक कंपास है और उसको हम हॉरिजॉन्टल सरफेस पर रखते हैं तो बीएच की तरफ अलाइन होती है. अगर हम वर्टिकल रखते हैं तो बीवी की तरफ. And if it is free to rotate in both the direction, horizontal as well as vertical, then it will always align itself in the direction of net magnetic field. A compass has tendency, or in fact any magnetic dipole has a tendency to align itself in the direction of net magnetic field. बट अगर कोई कंपस हमने रख दिया, कंपस में क्या होता है, इट इज नॉट अलाउड टू रोटेट इन बोथ द प्लेन, इसमें ऊपर एक नेल लगी होती है, एंड दैट्स व्हाई इट इज ओनली फ्री टू रोटेट इन हॉरिजॉन्टल प्लेन। जो कंपस हम लैब में यूज करते हैं, मैग्नेटिक नीडल जो यूज करते हैं, there is a specific type of dip compass called as dip circle, in which it is free to rotate in both x as well as y direction. करेक्ट। सो जब ये मैग्नेट दोनों डायरेक्शन में both the axis it is free to rotate, it will always align itself in the direction of net magnetic field. अगर हम सदर्न हेमिस्फीयर में तो हॉरिजॉन्टल से ऊपर की तरफ इंक्लाइन हो जाएगा, और अगर हम नॉर्दर्न हेमिस्फीयर में तो हॉरिजॉन्टल से नीचे की तरफ डिप हो जाएगा, एंड दैट्स व्हाई देयर आर टू डिफरेंट नेम्स फॉर द सेम टाइप ऑफ एंगल। नॉर्दर्न हेमिस्फीयर में हमें डिप मिलता है और सदर्न हेमिस्फीयर में वी गेट इंक्लिनेशन। एंगल ऑफ डिप कैसे डिफाइन करेंगे? It is the angle between horizontal component and net magnetic field of Earth at any place. Of Earth's magnetic field at any place. Are you getting this? बेटा ये डायग्राम समझ में आया? ये है क्या? अर्थ की मैग्नेटिक फील्ड का ही साइड व्यू है, हम अर्थ के साइड से देख रहे हैं। तो हमें जो अर्थ की मैग्नेटिक फील्ड दिख रही थी, ये नीचे साउथ से निकल के ऊपर नॉर्थ की तरफ जा रही है। वी जस्ट ऑब्जर्व दिस साइड व्यू। ये डायग्राम समझ आ रहा है? Are you getting this or should I do
Yes, sir.
some? Okay. Kanan, Rudra, Aradhya, this diagram is clear or should I show on the board? Is it clear?
This is clear.
साउथ पोल से मैग्नेटिक फील्ड परपेंडिकुलर बाहर निकल रही है, जहां पे निकलती है सरफेस के हमेशा परपेंडिकुलर होती है। सो एट द पोल्स देयर विल नॉट बी एनी हॉरिजॉन्टल कंपोनेंट, एट द इक्वेटर देयर विल नॉट बी एनी वर्टिकल कंपोनेंट, एंड एट एनी अदर प्लेस सदर्न हेमिस्फीयर में हॉरिजॉन्टल से ऊपर, दैट्स एंगल ऑफ इंक्लिनेशन। इन द नॉर्दर्न हेमिस्फीयर इट इज बिलो द हॉरिजॉन्टल, कॉल्ड एज एंगल ऑफ डिप। सो the angle between horizontal component of Earth's magnetic field and net magnetic field, that angle is called angle of dip. The angle between horizontal component of Earth's magnetic field and net magnetic field. And net magnetic field is defined as angle of dip or angle of inclination. As you can see from the diagram also. So vector B has two component BV BH, और उसका जो resultant है that is B. So resultant की direction निकालते हैं, tan delta is perpendicular component divided by base. So tan delta is BV by BH. That is the formula to calculate angle of dip. BV is the vertical component of Earth's magnetic field. BH is horizontal component of Earth's magnetic field. Rahul, BV is the vertical component of Earth's magnetic field. Vertical is always perpendicular to the surface and BH is parallel to the surface. Horizontal component. Net magnetic field at any place will be root of BV square plus BH square. एक तो ये फॉर्मूला मिल गया. BH will be B times cos delta and BV will be equal to B times sin delta. Whichever formula is required, we will use. तो जैसे ये part उतना important as such numerical के लिए नहीं होता, but in some question the information is given in terms of the angle of dip and the net magnetic field. Now you have to decide whether we have to use horizontal component pH or vertical component, right? Then we will have to decide whether it is cos delta or sin delta. This diagram is clear again. So horizontal what is the angle of dip at poles? What is the angle of dip at poles? At the poles of the earth? What should be the value? Are you getting my question? Poles पे angle of dip की value कितनी होती है? है?
Yes, sir.
What should be the angle of dip at poles? By the definition, it is the angle between net magnetic field and the horizontal. At poles, horizontal में तो कुछ है नहीं, ये perpendicular ही है, surface
Yes,
के यानी
sir.
horizontal के. So what is the angle of dip at poles? 90 degree.
90.
Poles पे the magnetic field is perpendicular to the surface. Angle of dip is 90 degree. At equator, the net magnetic field is in the direction of horizontal component only. So there is no angle, which means it is horizontal component of Earth's magnetic field is at equator. Angle of dip is 0 degree because दोनों के बीच में कोई angle नहीं, दोनों same direction में. Right? Okay, poles पे 90 degree, equator पे 0 degree. ये तो हो गए अर्थ की मैग्नेटिक फील्ड के दो स्टैंडर्ड एलिमेंट. हमें इन तीनों के बारे में पता होना चाहिए, तभी हम उस मैग्नेटिक फील्ड को किसी पर्पस के लिए यूज कर पाएंगे. We'll be able to determine its value. We'll be able to determine the direction only when we have these all the three informations, right? Any magnet, when it is free to rotate, it wants to attain the stable equilibrium state, so it will always align itself in the direction of the magnetic field. Yes?
Sir, can you move to the previous page for a minute?
Yes, boss. Done, Bharat?
Yes.
Okay. So horizontal component of Earth's magnetic field is the one which is parallel to Earth's surface, which comes out BH is equal to B cos delta. Vertical component is B sin delta. So अब किसी भी place पे अगर हमने compass रख दिया, if it is kept on a table, suppose, जो कि हम lab में use करते हैं, let's say we have a magnetic needle and we are using it. तो इसका जो needle का north है वो किस तरफ को point करेगा? This will be pointing in the south to north direction, which means it is pointing in the direction of magnetic meridian horizontal component, right? अगर हमने इसी टेबल पे इसको वर्टिकल करके रख दिया, this needle is kept now vertical. अभी ये पॉइंट करेगा अर्थ की डायरेक्शन के परपेंडिकुलर, तो अर्थ के लॉन्ग तो BH है, परपेंडिकुलर में कौन सा कंपोनेंट है, तो दिस कंपोनेंट इज नाउ इन द डायरेक्शन ऑफ BV। BH हॉरिजॉन्टल कंपोनेंट, BV वर्टिकल कंपोनेंट। और अगर वो डिप सर्कल है, दिस इज द निडल, always magnetic needle or compass will align itself in the direction of one of these, either BH or BV, depending upon how it is placed. Or if there is any other magnetic field, not just the earth, if there is any other magnet placed nearby, then there will be some change, और उस नई net magnetic field की direction में the pointer or the needle will be pointing. अर्थ की मैग्नेटिक फील्ड में जैसे हमें मैग्नेटिक मेरिडियन चाहिए। मैग्नेटिक मेरिडियन क्या होता है? मैग्नेटिक मेरिडियन इज अ प्लेस टू व्हिच इज पासिंग, लाइक सपोज हमें गुड़गांव का मैग्नेटिक मेरिडियन पता करना है, तो गुड़गांव के सेंटर में जाके वी ड्रॉ अ प्लेन, उस प्लेन में जिसमें दोनों BH और BV लाई करते हो, द प्लेन इन व्हिच बोथ मैग्नेटिक हॉरिजॉन्टल कंपोनेंट and vertical component lies, and that place should be passing through the center or through the point which you are. So horizontal component will be BH and vertical component will be BV, and this plane will be called magnetic meridian at any place. मैग्नेटिक मेरिडियन वो प्लेन है जिसमें अर्थ की मैग्नेटिक फील्ड के दोनों कंपोनेंट एग्जिस्ट करते हैं, पासिंग थ्रू द नॉर्थ एंड साउथ पोल। अब अगर हमने इस प्लेन में रखा तो जो हमें डिप एंगल मिलेगा दैट इज ट्रू डिप एंगल। नेक्स्ट कॉन्सेप्ट इज ट्रू एंड अपैरेंट डिप एंगल। हम थोड़ा शॉर्टकट में करें कि इसकी बहुत ज्यादा कॉम्पिटिटिव एग्जाम में वैल्यू नहीं है, बट अंडरस्टैंडिंग की बहुत ज्यादा। If this topic is not clear, what is dip, what is the declination, what is inclination, there will be many theoretical questions that you won't be able to do. Right? So true and apparent dip angle. True dip angle is always in magnetic meridian. True or actual dip angle at any place lies in magnetic meridian. BH, BV. दोनों का resulted आ गया भी. So in this plane, if we keep a dip circle, वो dip circle net magnetic field की तरफ जाएगा, so it will dip by an angle delta. The actual dip angle lies in magnetic meridian plane, और इसको हम कैलकुलेट करेंगे tan delta is BV upon BH. राइट, ये तो हो गया एक्चुअल डिप एंगल। अब प्रॉब्लम ये है कि जिस पॉइंट पर हमें मैग्नेटिक मेरिडियन चाहिए था, हमें मैग्नेटिक मेरिडियन मिला नहीं, किसी और प्लेन में हमने गलती से मैग्नेटिक कंपास रख दिया। अगर हमने इस प्लेन के साइड में कोई दूसरा प्लेन रखा हुआ है which is inclined at an angle theta, and if we keep the magnetic needle in that plane, ये एक नया प्लेन है, प्लेन P, which is not a magnetic meridian. It is inclined at angle theta with magnetic meridian. With respect to magnetic meridian. करेक्ट बेटा, ये समझ रहा, डायग्राम समझ में आ रहा है? ओपन बुक की तरह, वन पेज ऑफ बुक इज टुवर्ड्स मैग्नेटिक मेरिडियन, यानी इस प्लेन को आगे करते जाओगे तो दिस इज टुवर्ड द नॉर्थ मैग्नेटिक पोल. इज द डायग्राम क्लियर? पीछे वाला प्लेन मैग्नेटिक मेरिडियन है, हमने मैग्नेटिक मेरिडियन ढूंढने की कोशिश की बट मिला नहीं, तो मैग्नेटिक मेरिडियन से थीटा एंगल पर एक प्लेन रखा और उसमें कैलकुलेट कर लिया एंगल ऑफ डी. अब इन दिस न्यू प्लेन द हॉरिजॉन्टल कंपोनेंट विल नॉट रिमेन BH, देखिए BH का भी कंपोनेंट आ गया, it become BH cos theta only. BH cos theta और BV का जो नया रिजल्टेंट आएगा, लेट्स से B dash, that B dash will be in this new plane जिसकी डायरेक्शन में magnet will be B dash is in this new plane where component is BH cos theta and BV. Resultant is B dash and the apparent dip angle is delta dash. Tan delta is BV upon BH. अब ये tan delta dash क्या हुआ? इस मैग्नेटिक मेरिडियन को छोड़ के एक दूसरा प्लेन लिया हमने जो उससे थीटा एंगल पर है. In a plane inclined at an angle theta with magnetic field, at an angle theta with magnetic field, in a plane inclined at an angle theta if the apparent dip angle is delta dash. क्या होगा फिर? tan delta dash tan delta dash will be BV upon BH cos theta. BV बड़े वाले कंपोनेंट का और BH cos theta हॉरिजॉन्टल कंपोनेंट का. बेटा समझ आ रहा है? थोड़ा सा डायग्राम पीछे है, एक बार समझ लेते हैं. जो पीछे वाला प्लेन था ये मैग्नेटिक मेरिडियन है. मैग्नेटिक मेरिडियन में अगर डिप सर्कल रखते तो एक्चुअल डिप एंगल मिल जाता, उससे हमने थीटा एंगल पे किसी दूसरे प्लेन में रख दिया बाय मिस्टेक या जानबूझ के. In that new plane at an inclined angle theta, what will be the magnetic? What will be the angle of dip? उस केस में BH the whole BH is not acting on that particular component on that particular surface. BH का भी एक component आ जाएगा which will be BH cos theta and only राइट. सो BH cos theta और BV ये दो वेक्टर आ गए, एक हॉरिजॉन्टल कंपोनेंट एक वर्टिकल कंपोनेंट, दोनों का रिजल्टेंट है B डैश और रिजल्टेंट के डायरेक्शन में नेट dip circle will align, therefore it will be dip by an angle delta dash when tan delta dash is BV upon BH cos theta.
So can you explain this again?
I think we require a 3D diagram. So should I go to the board or is it working? No,
So I think board पे अच्छा रहेगा.
I think board will be better. Yeah, just give me because it is a 3D figure. Yeah. Is it visible? Board is visible.
Yes, sir.
Yes, sir.
I think audio might be slightly off, but okay, let's try to understand what it is. So there are two planes. There are two planes. We are talking about a magnetic meridian. Like suppose this place of Earth, the Gurgaon, where this academy is present. If suppose I want to check the magnetic meridian. Like which place is magnetic meridian. So what will be the first step? We'll have to use a compass. We'll have to use a compass. We'll try to just illustrate. We compass को कह रहे हैं. We will be first showing where it is pointing. So suppose if it is pointing in this particular direction, then that is magnetic meridian. It has one horizontal component, one vertical component, but not necessarily the plane of board will be a magnetic meridian. We don't know. That will depend upon where does the compass lie. If we assume that this is magnetic meridian, assume that this place on this place, this plane of the board is magnetic meridian plane. One component BH, which is the parallel to Earth's surface. Another component is BB, which is perpendicularly, maybe downwards into the plane or maybe upwards. In this particular plane, if you place a dip circle, it will be inclined in the direction of the net magnetic field called as which will be inclined at angle delta. Actual dip angle is always in magnetic meridian plane. In the magnetic meridian plane, if you calculate the tan delta is BV divided by BH. Equation number 1. This is magnetic meridian plane. This is magnetic meridian plane. Horizontal component is BH, vertical component is BB, and there is a net magnetic field at an angle of delta. But अब हमने ये plane choose नहीं किया, हमने इसी place पे अर्थ से theta angle पे inclined another plane. This plane is plane magnetic meridian. The other plane is another plane which is not magnetic meridian. दोनों के बीच में angle है theta, slightly declined or slightly another plane. Magnetic meridian is this plane of board. We have considered another plane which is touching to the board, but is not the plane of board. This is some other plane, right? So उस plane में जो हम angle measure करेंगे, in that plane, it will not be the actual dip angle. That's called apparent dip angle. दोनों के बीच में angle है theta. This is another plane which is called as P here, and it is inclined at angle theta with respect to magnetic meridian. In this plane P, the vertical component is still BV, but the horizontal component is changed. It is now BH cos theta. It is now BH cos theta. So in this new plane, the perpendicular, yes, Is there any doubt? बेटा यहाँ तक कोई समस्या?
फिर से बता दो, so this is confusing.
हाँ बेटा?
So फिर से बता सकते हो? This is confusing.
Still confusing?
Yes, sir.
It is a 3D diagram, so you'll have to take it a 3D angle. There is a book kind of thing. One page of book is magnetic meridian. Another page of that book is that plane P, which is having an angle theta between you. Right, so it's like an open book. One page of book is representing the magnetic meridian, the plane in which BH is there. This is magnetic meridian. I should have started on board only, but okay, no problem. Magnetic meridian is one plane जो किसी के किसी भी पॉइंट से पास वगैरह प्लेन है, which is fixed. Magnetic meridian is fixed. There is only one magnetic meridian passing through this plane. That may not be this board. I have assumed that this board is the magnetic meridian. So one component parallel towards this BH, another component perpendicular is BV. But now we are not choosing the magnetic meridian. We are taking from the same place. We are considering another plane which is inclined at angle theta, but it is not the plane of the board. Board से theta angle पे हमने कोई दूसरा plane ले लिया है. In that plane, if we place the dip circle will again be going down. But it is not because of B, it is now inclined towards B dash. और इस new plane में जितना dip होगा, that will be called apparent dip angle in this new plane P. Magnetic meridian के plane में जितना वो magnetic needle नीचे जाएगा, that will be actual dip angle. This is actual dip angle. In this plane P, if you place a magnetic meridian, वो जितना dip करेगा, that will be called apparent dip angle. In this plane, this is not magnetic meridian, which is inclined at an angle theta. इसके साथ थीटा, मैग्नेटिक मेरिडियन के साथ थीटा एंगल पे हमने एक प्लेन चूज किया है. इन दैट प्लेन द मैग्नेटिक कंपोनेंट्स ऑफ मैग्नेटिक फील्ड इज BH cos थीटा. ये BH का वो कंपोनेंट आ गया और दूसरा वर्टिकल में BB सेम इन प्लेन P. Again apply the formula for dip angle. So plane B में कंपोनेंट है वर्टिकल का BB, हॉरिजॉन्टल का BH cos थीटा, दोनों का रिजल्टेंट है B dash, which is at an angle of delta dash. Tan delta dash is perpendicular upon horizontal component, so BB divided by BH cos. Arnav, is it clear now?
Yes, sir. तो करने का पॉइंट क्या था वैसे?
अभी आते हैं एक और डायग्राम नेक्स्ट कॉन्सेप्ट समझ में आएगा. बिकॉज मैग्नेटिक मेरिडियन आइडेंटिफाई करना थोड़ा मुश्किल है. हम किसी भी प्लेन में
So you're mute.
Sir, you're muted.
So you're on mute.
Vaibhav sir, you put yourself on mute.
guys actual dip angle of this place of Earth.
So could you just repeat what you said? The thing got muted on its own.
Okay, I said last there are two planes. If we can identify the actual magnetic meridian, तो dip angle मिल जाता है हमें direct. But usually that is not easily possible. हमने एक दूसरा plane लिया, plane B, which is inclined at angle theta, which is not magnetic meridian. There is some gap, some angle between them. In this plane, we are measuring the delta dash. अभी delta dash और delta दोनों के बीच में relation क्या है? Tan delta dash is BB upon BH cos theta, and tan delta is BB by BH. Substitute here BB by BH. So tan delta dash is tan delta by cos theta. That is the relation between actual dip angle and apparent dip angle between the two planes, which is inclined at an angle theta. ओके, इसका पर्पस क्या है वो समझते हैं. गुड क्वेश्चन. व्हाई वी रिक्वायर इफ वी हैव, ये तो है रिलेशन बिटवीन अपैरेंट एंड एक्चुअल डिपेंडेंस. this diagram and this relation is clear. कहां से आई? मैग्नेटिक मेरिडियन में BH and BV, उनका resultant decline dip हो रहा है by an angle delta. In this other plane, the component of magnetic field is BH cos theta and BV, and the resultant is B dash. In that B dash direction, it is going to dip by an angle delta dash. Purpose. इसका पर्पस एक दूसरे तरह के एग्जांपल से समझ में आएगा. तो सपोज हमारे पास मैग्नेटिक मेरिडियन है ही नहीं, मतलब सॉरी मैग्नेटिक कंपास नहीं. बिना कंपास के हम मैग्नेटिक मेरिडियन आइडेंटिफाई नहीं कर पाएंगे. जिस प्लेन में BH होगा उसके परपेंडिकुलर जो प्लेन है दैट इज ए मैग्नेटिक मेरिडियन. सो इंस्टेड ऑफ फाइंडिंग द मैग्नेटिक मेरिडियन व्हाट वी डू, हम कोई भी दो रैंडम से परपेंडिकुलर प्लेन ले लेते हैं. Two perpendicular planes P1 and P2. Earth के किसी भी प्लेस पे suppose at this point I take one as this edge, one this face, another is the other two walls. ऐसे दो perpendicular plane ले लिए हमने. Two perpendicular planes P1 and P2. Heading नहीं डालना है, heading बाद में समझेंगे. Because you asked what is the purpose of that derivation, so I'm just explaining. Suppose हमें यहाँ पे dip निकालना है. What is the angle of dip at this location? Right? Magnetic meridian find करना थोड़ा मुश्किल है. Compass भी stable नहीं होता है. That keeps on changing slightly because of the current magnetic field, because of some other magnetic field. So हम दो plane लेंगे. Suppose one plane is this wall, another plane is the other wall, side wall. So I am just drawing the top view. This is plane P1. And the other one is plane P2. Angle between them is 90. So this situation is like there are two perpendicular planes, and those two perpendicular planes are like this. Okay, P1 and P2. हम उसका top view देख रहे हैं. P1 is one plane, P2 is another plane. Angle between them is 90 degree. In that two different planes, we find out the dip angle. मैग्नेटिक मेरिडियन दोनों में से कोई भी नहीं है. हमने अज्यूम कर लिया मैग्नेटिक मेरिडियन कुछ यहाँ कहीं पे है. दिस इज सपोज मैग्नेटिक मेरिडियन, बट हमको इसको आइडेंटिफाई करने की जरूरत नहीं पड़ेगी. प्लेन P1 and plane P2. You understood the diagram? Understood the diagram? Two planes perpendicular to each other. जहां पर भी हमें dip angle find करना है. None of the two plane is magnetic meridian. दोनों में से कोई भी मेरिडियन नहीं है. बीच में कहीं होगी, बट हमने उसको आइडेंटिफाई नहीं करना है where exactly that is located. But if this plane P1 is inclined at an angle theta, the other plane will be inclined at an angle 90 minus theta. That is for sure because वो दोनों आपस में perpendicular थे. हम plane P1 in this wall we put the magnetic needle or dip circle और हमने यहाँ पे calculate कर दिया delta 1. We got the apparent dip angle in plane P1 as delta 1. क्या रिलेशन होगा डेल्टा 1 डेल्टा और थीटा में? यूज द प्रीवियस रिजल्ट जो भी हमने डिराइव किया है. tan delta dash is tan delta by cos theta. Tan delta 1 is equal to tan delta divided by cos theta. This is the relation we got from plane P1. पहले प्लेन में हमने एक डिप सर्कल रख के उसका एंगल ऑफ डिप मेजर कर लिया, which is delta 1. सिंस मैग्नेटिक मेरिडियन का डिप एंगल हमें फाइंड आउट करना है, we choose somewhere in between.
Sir, you again have put yourself on.
In plane P2 में apparent dip angle is delta 2 and the delta is actual dip angle. So tan delta 2 by the same logic it will be tan delta divided by cos of 90 minus theta, which is the second. Cos 90 minus theta becomes sin theta. So tan delta divided by sin theta. Second equation. अब हमने डेल्टा 1 मेजर कर लिया, डेल्टा 2 मेजर कर लिया, and we have to calculate delta. So by using these two results, we can eliminate theta. Sin square theta plus cos square theta is 1. Sin theta will be tan delta by tan delta 2. Cos theta will be tan delta by tan delta 1. Is equal to 1. By using this identity, sin square theta plus cos square theta is equal to 1, we eliminated. Now इस पूरे में हम tan square delta से divide कर देंगे. 1 plus tan square delta plus tan square delta 1 is 1 plus tan square. Arnav, you understood this?
Yes, sir.
Yes, sir.
The last derivation was only to get to this result. Practically, अभी तो हमें कोई मतलब नहीं है. We don't have to do. We have to solve a numerical. Practically, what that derivation is used for? किसी भी random से plane का अगर dip angle पता है और actual magnetic meridian के साथ दोनों के बीच का angle, then we can relate them by this. And choosing two perpendicular planes, measuring their delta 1, delta 2 easily, quite easily, rather than finding the magnetic meridian, we can determine the actual dip angle at any place on Earth. Why magnetic meridian find is very difficult to find? Because there is always some or the other magnetic effect. That's why the needle is not very stationary and it's little complicated to get the exact magnetic meridian thing. ये जो result है, we can also write in terms of cot square delta 1 plus cot square delta 2 is equal to cot square delta. अर्थ की मैग्नेटिक फील्ड का पर्पस है यूजुअली नेविगेशन के लिए, प्लस इन द सेंसिटिव डिवाइसेस लाइक gyrometer.
Sir, you put yourself on mute.
Okay, you noted this down. So I'll switch back to tablet. थोड़ा speed faster हो जाएगी. You noted it down, Bharat?
Yes.
Understood this? थोड़े
Yes, sir.
practical की चीज थी ये, but ठीक है, it was I mean it was a genuine question, why we require this nonsense delta dash and delta, but yes, practical use is there. हमें भी सिर्फ question solve करना है numerical, and the application was that with that we can find out the actual dip angle.
Yes, I was wondering कि हम एक और plane क्यों ले रहे हैं इसमें, but now I know.
Phone is quite disturbing these days. Okay, so ये कैसे थोड़ा टॉपिक था, but हमें थोड़ा ज़्यादा टाइम लग गया. But anyways, we will be using this for the next chapter. जैसे when the aircraft flies, aircraft के wings में कुछ magnetic कुछ EMF develop हो जाता है across the aircraft wing, and in fact in the space shuttle that is used also for charging some batteries, right? Okay, so I think our magnetic field के कुछ questions आप SL से कर लेना, and then we will do in the next class. थोड़ा I will start on the board only next class, because ये दो chapters जो अभी बचे हैं, induction and all in the magnetic field, it requires some visualization.
So,
ठीक है. Okay then, I think.
Vaibhav, sir.
Yes, beta.
When will we start with EM waves, given that in my school it has already been started?
In AP sir's class, it must have been started, I think, or maybe it is going to start. Arnav, what is the status? Arnav?
So I can't recall what you were doing in AP Sir's class. I'll revise it again.
No, in AP sir's class, what is going on?
So I'll have to check my notes. It's kind of far.
I think it was at AC, so alternating current. उसके बाद अगला topic EM waves है, so Bharat, you have to attend there, because for us it will take at least 5 classes. At least. Induction is a big chapter, electromagnetic induction. चलो ठीक है, कोई बात नहीं. Next class will take on the board only, so that this time wastage is not there. At least for this whole unit, the magnetism unit. Aradhya, you understood this? These two diagrams?
Yes, sir.
Okay, sure. So we'll continue on Thursday. Thank you.
Thank you, sir.